Welcome to Learning with Philemon. In this video, we will be looking at how to apply the ideal gas law. In the previous video, we learned that a gas that behaves ideally follows the equation PV equals nRT. For more on the assumptions made in order to use this equation, please watch the previous video, Ideal Gas Law. When using this equation, it is important to know what units are used for each quantity. P stands for pressure and is measured in pascals, PA. V stands for volume and is measured in meters cubed. N stands for number of moles and is measured in mole. R is the gas constant, which is equal to 8.31 joules per Kelvin per mole. This constant can be found in the IB data booklet. T stands for temperature and is measured in Kelvin, K. Note that when at standard temperature and pressure, 273.15 Kelvin and 100 kilopascals, 1 mole of any gas has a volume of 22.7 decimeters cubed. Under these conditions, it is not necessary to use this equation. For more on solving questions without PV equals nRT, watch the video Molar Gas Volume. Note that in that video, 24 decimeters cubed is used instead of 22.7 as the reactions are at room temperature and pressure, RTP. The same method applies, however. When we are not calculating at STP, then we need to use this equation. However, we often get data that are not in the standard units used. You need to learn how to convert to these units before substituting the values into the equation. Pressure is sometimes given in kilopascals, kPa. The prefix kilo means 1,000, 10 to the power of 3. So 1 kilopascal is equal to 1,000 pascals. Volume is sometimes given in decimeters cubed. 1 meter is equal to 10 decimeters, so 1 meter cubed is equal to 1,000 decimeters cubed. To convert from degrees Celsius to Kelvin, we need to add 273.15 to the value in degrees Celsius. Let's see now how we can apply this equation. A typical question would be 0.5 moles of hydrogen gas are stored at 150 kilopascals and 100 degrees Celsius. Calculate the volume of the gas in decimeters cubed. We are trying to determine the volume of hydrogen gas. So the first step is to rearrange the equation so that the volume is the subject. V is equal to nRT divided by P. The second step is to convert all the units to the standard units. 150 kilopascals is equal to 150,000 pascals. 100 degrees Celsius is equal to 373.15 Kelvin. Substituting in these values to this equation, we get the following calculation. The volume is 0.01 meters cubed. To convert the volume to decimeters cubed, we multiply by 1,000. The volume of hydrogen gas is 10 decimeters cubed. Note that the answer is given to one significant figure, as the number of moles are also given only to one significant figure. Now let's see what other questions could be asked. This question asks, in an experiment, it was determined that 82.84 grams of a monoatomic gas had a volume of 50.00 decimeters cubed at 200.0 kilopascals and 293.15 Kelvin. Calculate the molar mass of the gas and its identity. To determine the molar mass, we need to determine the number of moles, as we already know the mass of the gas. Rearranging the equation so that number of moles is the subject, we get N is equal to PV divided by RT. The second step is to convert all the units to the standard units. 50 decimeters cubed are equal to 0.05 meters cubed. 200 kilopascals are equal to 2 times 10 to the 5 pascals. Substituting the values into this equation, we get the following calculation. There are 4.105 moles in the sample. To calculate the molar mass, mR, we divide the mass, m, by the number of moles, n. The molar mass is equal to 20.18 grams per mole. Note that the answer is given to 4 significant figures, as all other values are given to 4 significant figures. Checking the periodic table, the element with a molar mass of 20.18 grams per mole is neon, Ne. Note that neon is a noble gas and rarely bonds with other elements. Neon is a monoatomic gas. This means that the neon atoms are not bonded to each other. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.